In this scene, I already have a light source created, and I have a mesh that was imported through FBX from the outside. I have my Krakatoa settings, but I actually don't have any particles. If I would render now, nothing will really appear. So in the Krakatoa shelf, we have a bunch of icons. The green icons create particle objects. PRT creates particle loaders. Vol creates a particle volume from mesh. This is what we'll be doing. And FRA is show for fractal that creates a procedural fractal 3D distribution. We'll take a look at the other buttons a little bit later. So I'm going to just hit the icon that says vol, and this creates on the fly from the mesh of the object that I had selected, creates a particle cloud. And I'll move my render dialog a little bit to the side in order to take a look what controls we have. I'm going to change the render spacing to 1. Currently in the viewport, we'll see that we're using 3.9. If I change this number, you'll see that we're actually repopulating the volume on the fly. What is happening is this mesh is being taken and converted to a level set, which is a bunch of voxels, and in each voxel, one particle currently is being created. That's why we're getting a grid. So this is just a preview in the viewport. At render time, we'll be using the render spacing, which is 3 times more dense. But this is still not enough to actually create a nice looking result. I'm going to hit the render button and take a look at the result, and we actually see the grid there because we don't have enough particles. If I take a look at the output window, this created only 353,000 particles. And as I mentioned, below 1 million, you're not really doing anything in Krakatoa. So if I check the option that says, instead of reducing the spacing, which will increase the resolution of the level set and actually slow it down because it's ray tracing a mesh to figure out all the voxels, I can take the existing voxels and subdivide each one into 8 sub-voxels, and then in each one of them, a new particle will be created. And if the particle happens to be inside the volume, and it's checked against the surface of the level set, and if it's inside, it will be left, and otherwise it's not created. If I do this and hit render, it will render a little bit better. That means it will be a lot more solid. But the number of particles is still not that high. It's only 2.8 million points. That took 2.4 seconds to actually illuminate and render. And I could go with actually another increment up with 2 subdivisions. That means that each of the voxels will be subdivided into 27 sub-voxels. This will create over 9 million points, and it will be pretty smooth. There will be no artifacts on the belly of the statue, and not that they're very obvious, but it's actually, this is much smoother. It took about less than 8 seconds to render, and the number of particles is 9.5 million. Yeah, it was 7.9 seconds, the whole render time. At this point, we have something that looks pretty much solid, and using the particle volume, the PRT volume object with geometry is very nice for actually testing Krakatoa without having a real world heavy point cloud from a real source. That means if you're starting with Krakatoa and the first thing you want to try is see how 10 million particles render and how long it takes and how to use shaders on that and how to control lighting and so on, the PRT volume is a very good starting point because it allows you to actually experiment with very dense point clouds, but it takes almost no time to create them. If we take a look again, here the generation time, including the actual getting of the particles into memory, was 2 seconds for 10 million particles. So I'm going to open now the render settings and take a look at some of the options that we have. An important part of the dialog is the lighting and drawing pass, density and filtering. And basically, Krakatoa takes each particle as a point that carries certain amount of data, which is typically the color, eventually emission information, absorption information. It obviously has a position that defines where in space it is, but the density is the value that actually defines how that particle is going to affect the volume that it falls in. So when Krakatoa is rendering, it takes a bunch of densely spaced particles, and each one of those particles brings certain density with it. That means if it has a value of 0 and you put 10 particles there, you get a density of 10 accumulated. And if they all cover the same pixel, then the pixel in the final image will represent a volumetric density with a value of 10, and the alpha will get more solid. If you have a very low density value, then obviously the whole thing will start getting more transparent. And since the scale of the scene matters a lot, we are using volumetric units, which are more or less spatial, like you can think of it as a voxel with size of 1. That means if you put one particle with a value of 1 in a voxel that has sides 1 by 1 by 1, you're going to get in that volume the density of 1. If you put 100 particles with a value of 1, you're going to get 100, but if each particle had 0.01, then you're going to still get 1 when they accumulate. So we have various ways to control that, but there is a top-level global control, which is the final pass density, and currently it's set to 5 with exponent of -1. The reason we're using an exponent is that sometimes we have to deal with very large and very small numbers, and using typing 0.00005 is really a bad thing, and it's very difficult to even read. It's much easier to say, okay, I'm going to use 5 and with a certain number of zeros in front of it. I want 5, I want 4. When you set it to 0, then 10 to the power of 0 is 1, so you get exactly 5. If you set -1, then you get 0.5. Now it's 0.05 and so on. So I'll go actually to this 0.05 and I'll hit render, and this will create a much more transparent object. It will create the particles, light the particles, and draw the particles, and we're actually getting, looking in the alpha, a semi-transparent statue, and the light, of course, is passing deeper through it, and you see that this is not just a surface, this is a complete volume filled with particles, so it creates forward scattering, light is being attenuated, and you get shadows and so on. Now, what if I wanted to actually keep the original density that I had before, but affect only the lighting, to pretend that the density relative to the light source is lower than it is relative to the camera? I can decouple the density, and in this case, if I hit render, I'm going to get the same light distribution that we're seeing here, but the actual alpha and correct opacity of the statue as we had before. So the alpha is now solid, and the light is still penetrating the volume much better. This is very useful when you want to tweak something, not to be physically correct, but to be what the director wants, or your customer, or you want to achieve. So it was kind of important to create some controls that allow you to tweak the data without trying to stay physically correct all the time, because the final result is what counts, and if it looks good, then it is good. Additionally, we also acquired data from the mesh that we're sampling. That means our object, for example, has normal vectors acquired from the geometry that was sampled, and this allows me, for example, to switch to funk shading, and hopefully this will render more like a metallic object, but still have some transparency relative to the light source, and it will render as a volume. Now it actually renders as a metal, but there is potentially light that would be distributed through the volume. I'll switch back to isotropic, which is the default mode, and just scatters light in all directions. And I'll take a look at a couple of other controls inside the PRT volume, so we cover all that stuff. One important control that we have is the jitter. If I would disable the sub sampling and render with just the diffuse grid, you can start seeing the actual grid distribution. So if I want to get rid of that, I can check the enable random jitter option, and you can see in the viewport also, as well as in the render dialog, that it creates a spongy look. In fact, somebody sent me an image of SpongeBob SquarePants made from Krakatoa particles, and it looked very spongy. There is also an option that disables the subdivisions in the viewport. That means that if you enable one subdivision and uncheck this option, the viewport will represent exactly what the renderer would see, even though it's using the viewport's spacing. Normally it's checked so you don't get too many particles in the viewport and keep it fast and usable. I'll bring it back to the two subdivisions. We also have an option to create surface shell. I'm going to show you a similar example with a different scene. I have a bunny here, and I could do exactly the same trick, create a PRT volume. I can enable the random jitter if I want. I can enable the surface shell. And if I start changing this value here, you'll see that I'm actually creating particles only within a very thin shell around the surface. And if I start changing the surface shell start, I can actually grow the whole volume from center out. So this can be used for special effects where something actually grows out of nothing and fills a volume. But the interesting thing is, if I open now the render dialog and make sure that Krakatoa is assigned as the renderer and hit render, you'll notice that nothing happens. Actually, something happens, but you don't see it. It's completely black. It said that the rendering took less than 1 second. And if I take a look at the alpha, I see some points there. So the rendering actually worked. I could switch this one to 0.1, which will give me relatively nice density in the alpha channel. And you can see the outline, and I can make it thick and so on. But the RGB doesn't show anything. And this can be confusing when you're starting with Krakatoa for the first time. You might prepare the scene, hit render, nothing happens. And the reason is Krakatoa doesn't really support a default light. So it doesn't have any lighting. And in this case, we are getting particles that rendered as black. Even though they would render as white if there was light, they don't because there is no light source. I could show you this by checking the background and hitting the render button, and then you will see a black bunny, and the RGB channel will get the black. And now it's obvious, but the first time you do that, you might be confused. And for that reason, we actually added a special area in the user interface of Krakatoa for Maya, which is called the sanity check. And if I click on the sanity check, it tells me what it has found about the scene that it doesn't like. And in this case, there is a warning that says no lights in the scene. Particles will render black RGB. To avoid this problem, you can do one of the following. You could create a new point light. You could create a new spotlight. You could enable emission and set override emission on in order to actually make them self-illuminated. So there will be emissive particles and they will be glow in the dark. Or I can check the force additive mode, and if I do this, I'm going to get additive particles which will accumulate the white color and will be glowing again. But it will be completely transparent, won't have any alpha, because additive rendering doesn't really produce alpha. Now, the interesting thing about all this stuff is at the bottom it says to apply a fix for the reported problem, just double click one of the options that prefix it. They have a prefix with star in front. That means if I want to create a point light, I just double click on this one, and now I have a point light in the scene. And if I hit render, I will get some illumination passing to the bunny. Of course, that might not be the point light that you wanted. So if I delete that point light and create my own, see if I perform the check, it says the same. I could pretty much just go and say, yeah, I want to create a light. And then if I rerun the check, it will be fixed. But it's much easier to actually double-click one of those options. And as you see, I double-click the option force additive mode, and it checked the option in the UI. So it tells me what is wrong. It tells me what I can do, and it actually does it for me.